Linear inequalities really aren't something that we can solve in the sense that we solve equations. And the reason for that is the solutions here aren't individual points or even a finite set of points. Here we're going to see the solutions are regions in the plane. Right? So they're actually infinite collections of points. That's not something that we can really write down. What we can do is graph those solutions, and that's what we're going to focus on here. So I have a basic inequality for us to start with over here, y less than or equal to 2x minus 3, and I want to graph the solutions to this. There's a couple steps in the process. The first thing I'm going to do is take this inequality and convert it to an equation. So I'm going to make it y equals 2x minus 3. And I'm going to graph that. Now, that's obviously a linear equation, right? So it's going to be a line. And its y-intercept is negative 3, so it's going to go through this point here. And the slope is 2. So I'm going to go up 2 over 1 and get a second point. Now, because my drawing skills are pretty massively limited, I'm going to actually draw some more points just to give me more reference points, make sure my line looks reasonably right. So now I'm going to sketch the line through these points. And that line is the boundary to my solution. Right? So my solution is going to either be everything over here to the left of the line, or everything over here to the right of the line. And you got to figure out which side it is. Well, the way I'm going to do that is I'm going to pick a test point, and you can pick any points you like for this. Right? And anyone will work, except you cannot pick a point that's actually on the boundary line itself. So as long as I stay away from that line, I'm okay. I'm going to pick, same point I always pick when I can, I'm going to pick the origin. All right, so my test point is going to be 0, 0. Step 3, I'm going to take that test point and I am going to put it back in the original inequality and see if it works and see if it satisfies it. All right, so if I put 0 in there, I get 0 less than or equal to 2 times 0 minus 3. That's 0 less than or equal to negative 3, and that is not true. Right, that is a false statement. So what that's telling me is the origin over there is not part of my solution. And the way this works, that test point was kind of a representative for every point on that side. So if the test point wasn't a solution, then none of the points on that side were. Right? And that means all of the points on the other side, over here, over to the right, are my solutions. And to indicate that, I'm going to come up here and I'm going to shade in this side, right? And it takes a second because it's 16, 17 lines here, right? But you see where I'm going with this, right? All of the points in that shaded region are solutions to the original inequality. So let's try another one here. It's very similar. The only difference is it's not nicely solved for y like the previous one was. But we're going to handle this the same way. Step number 1 is graph the line 2y plus 3x equals negative 8. And to do that, I'm just going to put it into that slope-intercept form. I'm going to solve it for y. Right, so I'll move the 3x over. 2y equals minus 3x minus 8. And then divide both sides by 2. Y is negative 3 halves x. There's my slope. And minus 8 divided by 2 is minus 4. All right, so let's graph this. The y-intercept is down here at negative 4. The slope is negative 2/3. Excuse me, the slope is negative 3 halves. So I'm going to go down 3 and over 2. Again, I'm going to repeat this over here a few times, give myself some reference points to make my final graph look a little better. Right, now I'll draw the line through here, and we need to pause for a second, because this inequality actually is a little different from the other one. The last one had greater than or equal to in it. where this one just has greater than. And we need a way to distinguish those two types of inequalities. The way I'm going to do this is I'm going to draw a dashed line here, where if you look back, you'll see I used a solid line on the previous solution. Right? A solid line indicates that the points on that boundary region are part of are solutions to the inequality. A dashed line indicates that the points on that line are not part of the solution. Okay, so now I'm going to do the same thing I did before, right? The origin is not on the line, not on the boundary line, so I'm going to use that as my test point. And if we put that into the inequality, 2 times 0 plus 3 times 0 is greater than negative 8. That left side is just 0. You see why I like to pick 0 for my test point? 0 is greater than negative 8. Right? That is a true statement. So the origin is a solution to the inequality. So everything on the same side as the origin is part of the solution. So I'm going to shade everything over here. Again, takes a second. Trying to be reasonably neat. Right? This whole, it's called a half plane, that's a technical term for it, represents the region where all of this inequality's solutions lie. Right? And there's my solution. So I've got one more here for us to look at, and these are a little unusual because you see there's only one variable in each inequality. That's okay. Right, we're going to graph these exactly the same way. I'm actually just going to go ahead and put both of them on the same set of axes here. So for the first one, I'm going to graph y equals 2. Right? Y equals 2, that's a horizontal line going through this point here, right? The point up 2 on the y-axis, and I'm going to use a dashed line because I have strictly less than in the inequality. Right, now I'll pick a test point. I'll use the origin, 0, 0. And I'm not going to be bothered by the fact that there's no x there. That's perfectly okay. Put 0 in for y. 0 less than 2. That's true. Right? So the origin is part of the solution, and my result is going to be everything below that line. Again, it takes me a second to draw this in. And there's my result. There's my graph of the solutions. All right, and the x's, we do these the same way. Right? I'm going to graph x equals negative 1. And that is a vertical line, and I'm going to do a solid line for this because it's greater than or equal to. Right, so I'm going to put a solid line right here. And we'll test the origin again. And again, I'm not bothered by the lack of a y. I have my x value at 0. 0 greater than or equal to negative 1. That is also true. Right, so the origin is part of the solution here as well. So I'm going to graph, well, let me use the same color. I'm going to graph everything over here. And this half plane represents the solutions to that second inequality.